is a moth. Underneath it would be the flower that the moth feeds on. This moth, while being unfortunately Pinocchio-like, did not start lying just to grow his nose. In fact, that's not his nose, it's his proboscis. A proboscis is essentially a tongue-like structure used for feeding. Anytime you've been bitten by a fly or a mosquito and you feel that stabbing pain and you see that thing sticking into you, that's the proboscis. Oh, biology's fabulous. This moth did not sit and consider that it would like awfully very much to have a long proboscis. Rather, the moths in the previous generations that were more successful on feeding on the pollen of this particular flower were those who had a longer proboscis. And over generations, the ones who fed more produced more moth offspring until the entire population looked like this. These two species evolved together, so we call this coevolution. But it's the entire population that looks like this, not just this one moth. So it operates on populations and not individuals. Don't worry about this poor moth. He's not getting like left out at the lunch table. He's not like the weird one because he has a really long proboscis and everybody else is this short. Everybody looks remarkably like him. Sometimes it's slightly longer, sometimes it's slightly shorter. You'll notice though that it's almost a perfect fit for that flower. It's not longer than the flower. For any moth that it's longer than the flower, the proboscis would stab out the back side of the flower, thus preventing feeding. So those proboscises, I don't know what the plural is, proboscis, those proboscis, those with ones that are too long, would not feed as well because they would stab through the flower, they would die. Selective pressure against one that is too long, selective pressure against one that is too short, selective pressure for just the right size, a la Goldilocks. Glad you guys didn't make fun of him, because imagine walking around with that attached to your face. Okay, flying with that attached to your face. Don't worry, it curls up when they fly, like a curly cube. Folds up, but it unfolds. Charles Darwin gave us the how. So we know the history of evolution. We know what we used to think. We know some of the competing theories. Then Charles Darwin did his whole Galapagos thing and gave us the how this happened. After he developed the how, he had to accumulate massive amounts of evidence, just like Mr. Broussard told us, right? Scientists love evidence. So Charles Darwin spent a long time accumulating evidence for evolution. And this is where you are going to discover there is actually a branch of science I'm not super keen on. See, most people think that all scientists love all branches of science. Not true. We all have our preferences. I personally like things that are alive. Living things do entertaining things, like you guys. You're entertaining because you're alive. Some of you more so entertaining than others. Like last hour, I had a student do that thing where it looked like they're going downstairs behind my desk. You know what I'm talking about? Anybody in here think they're really good at it? Don't worry, I actually had to badger the kid into doing it last hour. We did a slow clap until he did it.
Daniel's good at it.
Yeah, Daniel's obviously very good at it.
Evidence of fossils. You know what's not my thing? Rocks and fossils. Paleontology, never understood it. The idea of taking a truly tiny chisel and a little brush and patiently tapping away at a rock to find something that just looks like another rock. Never really been on my list of things to spend hours doing. And I will do, like, I've watched paint dry before. I have. It's really interesting with a thermal camera because you can see the different patterns in like the heat coming off the wall, right? That's cool. So, chemistry, I'm okay with it. Paleontology, not so much. That, and it turns out paleontology, you're usually in a desert. Not a great place to leave somebody from Northern Europe. Deserts, me, we don't get along super well. So paleontology's never been my bag, but I did gather enough understanding of it, and this is what last hour told me. They told me, well, here's how we get fossils. Take something that's alive, and then it dies. Is that not the universal symbol for dead? It was happy. Now it's dead. And then they told me last hour something along the lines of it's going to get covered by rocks. And then those rocks are going to stack up even farther on top of it. But before we do that, all the squishy bits have to disappear, right? So the squishy, fuzzy bits get taken away. And all of the calcium bits get replaced by a harder compound. So soft minerals get replaced by harder minerals like silica. And that's how we end up with a fossil. Charles Darwin knew that. In Darwin's era, they're like, yeah, no big deal. Yep.
Isn't silica this stuff they put in those purses and like those little white packages?
Mm-hmm. It's a desiccator. Desiccator means dries things out. The little packets that say do not eat.
Oh yeah, why do they?
Yeah, and then they put them in your vitamins. Anybody?
Oh
They
yeah,
put the little
I
packets.
have seen those.
My little cousin
Everything.
ate some
Yeah.
of those. Pretty bad.
I have a question for you, Robert.
I didn't.
What is your question? What is your cousin's name?
Don't share that.
Yeah, I don't want to tell
Which cousin? Just tell me.
you. She was like 3.
Alright, is she okay now? Like,
Yeah,
she doing great?
That is why they actually say keep out of reach of children.
Yeah.
Yeah, they're a desiccator. They dry things out. That's why they keep them with leather products, because leather products will absorb moisture if you don't. That's why they keep them with your vitamins, so your vitamin tablets don't get like squishy. So the idea is it keeps things hard. So it would make sense that we're going to replace all of the softer minerals with silica to form a fossil.
Yeah, question. It's
Mhm.
kind of related to this, but like since the thing you're talking about keeps the thing soft, like
Hard,
what are those
yeah.
little packets that keep the beef jerky things? Like do those like keep the beef jerky?
Oh yeah.
You know what I'm talking about?
Surprisingly enough, that's actually to keep the beef jerky dry. And if we don't keep the beef jerky dry, it's going to develop mold. And that's the opposite of the drying preservation technique that was desired. While you guys find jerky to be a delightful treat, people who used to eat jerky ate jerky because there was no other way to preserve a dead animal. And you wanted to preserve all of it and use all of it because if you're going to slaughter something, you should probably keep it for as long as possible.
Moldy beef jerky?
Random fact of the day. Aren't you glad you came to school?
Wasn't that why everybody on everything? Because it was
It's a preservation technique, absolutely. So, Charles Darwin understood that this is how we got fossils. And the people of Charles Darwin's time recognized and saw fossils that look like this. This is going to tax my biology art here, so bear with me.
Cleats. Face muscle.
It's a dinosaur.
Stegosaurus.
I still. Oh, it's a fossil. It's a
Oh, it's a
T-Rex. It's actually.
Oh yeah, it
Oh,
is.
she said T-Rex, Daniel.
Oh, that's
Yeah,
the
say it.
That's the ribs right there. The vertebrae.
And then like the hand.
Daniel.
So they saw fossils that looked something like this. Oh, we need scale, right? Scale is important.
Small dinosaur.
It's a baby dinosaur. I don't know. So they had fossils. They saw fossils. He had a mustache. I thought he looked smarter if I put glasses and a mustache on him.
Oh, is he looking at the
Where's the
dinosaur?
mustache?
Should have a monocle.
Oh, that's from the side of it.
Yeah, that's his side. He's looking up at the dinosaur.
That's so
Yes, it looks weirdly like Teddy Roosevelt and a paleontologist, okay?
What'd he say?
Teddy Roosevelt was rolling without pants. We got it covered now.
Wait, wasn't he in a wheelchair too?
No,
No, that was later.
No, wait, where's his horse though?
I thought he was
It's not nice at the museum, Rob.
I believe that's a movie.
Hey, you guys take a voice note, you guys
Oh, of course.
Not me.
It's a hobby horse.
There's a horse.
I love those. Wait, that's a unicorn.
That's its ears.
Actually, I have a hobby horse unicorn.
Really? I have like.
I found it at IKEA and I refused to leave till my husband bought it for me. So they saw these things and they recognized there's nothing on Earth that currently looks like this. Right? And they looked around and they're like, I see nothing else that resembles this, but it used to be. So they interpreted the fossil record in the same way that we still interpret the fossil record, as evidence of things that used to exist on Earth. But if they don't currently exist, that means they used to exist. They once were. Hint, things change. But not only did they discover that things change, sometimes really bad things happen and things change so quickly, the environment changed so quickly that everything died. What do you call an event where every member of the species dies?
Extinction.
An extinction. What are the 3 running theories for extinction for this particular kind of creature?
Meteor.
Meteor, right? Super large objects hurtling towards Earth. Hurtling usually implies at speed. Volcanic eruption.
Like an outbreak of a disease.
Viral infection. There are scientists who found a virus inside of mosquitoes that have been preserved in tree resin who are like, hey, it's possible all of the dinosaurs just got essentially like dino flu. And it wiped them all out. Those would be large, drastic events that happen quickly. How quickly does evolution happen? Slow. So if evolution is slow and the environment changes quickly, it causes extinction. It means that those things couldn't adapt as a population fast enough for survival.
Oh, shucks.
I know. Jurassic Park for us.
Jurassic World.
I don't even know what that means because I haven't seen any of them, so whatever.
Tom is like an actual dinosaur. It's like dinosaurs inside of it.
So, as we look at this particular picture, it's the second way that the people of Charles Darwin's time, and we still to this day, would interpret the fossil record. We call it a transitional form. What that means is they would say that we have an ancient ancestor and the modern equivalent, right? So the ancient ancestor of the toothed whale, the hypothetical creature that we think existed, and the modern ancestor. Along the way, there were steps in evolution. Things happened slowly over time, and we have evidence of transitional forms. That's why we call them transitional forms, because it means that it shows us that there were stops along the way, transitions, if you will. Looking at fossils also allows us to look at vestigial organs. That's a funny word. I'll write it down because it's a funny word. VESTIGIAL, vestigial organs or vestigial structures. Vestigial organs or structures are structures in an organism, so they're parts within an organism, that no longer have a function. They don't have a job. They don't have a purpose. There is no function. But they indicate that the ancestor had that body part at one point. It's not a good thing to have a vestigial organ or a bad thing. It's a null thing. It's neutral. So I'll give you actually an example of a vestigial organ. It should be on this slide that's not.
What about like the appendix?
Precisely like the appendix.
What if it explodes?
I remember how I said that humans do this weird thing where we totally monkey with evolution by rendering what would normally be a disadvantage neutral. That's what we do there. But most of you woke up today, in fact, hazard to guess, all of you woke up today and did not think, gosh, it sure is inconvenient that I have this appendix. Exactly, right? I have a feeling at this very moment, this is the first moment all day you guys have acknowledged the existence of your appendix. A lot of you have been carrying it around for like 14 years and probably have thought about it 5 times, maybe. And we don't think about our appendix because it doesn't affect our survival. We don't have to eat more because we have an appendix. When you guys go out to search for a spouse in the future, you're not going to be like, I'm going to marry that person because they have a fantastic appendix.
First thing I look for. First thing I look for.
I look for the personality, but.
No, but
Appendix is a close second.
Does evolution ever get rid of?
Only if it's a disadvantage. So the only time we would ever get rid of an appendix or we would get rid of a vestigial structure is if it is a disadvantage, if it affected survival.
I thought you said like towards the beginning of the year that like snakes had like legs and then they still have them, but now they have like skin over them.
Same thing with our whale's pelvis here. So you see how the whale has a pelvis and a femur? That means the ancestor of the whale. Are you now picturing a land-dwelling whale? You should be.
Wow, I would love to be scared. I was just
The vestigial organ tells us that it used to exist. It was there at one time. But this pelvis and femur is not an advantage or disadvantage for a whale. Doesn't matter. It's just there. Now some of you are like, but it's not attached to anything. It's just like floating in the whale. None of your bones are attached to each other. All that attaches your bones to each other are squishy bits, right? Tendons, ligaments, muscle, the squishy stuff. The only thing that keeps any of this together, squishy bits. It's okay that it's not attached. Don't stress about that.
For whales, do they still have like blood cells created in their femurs or the primary?
Like marrow?
Yeah.
I don't know. I would assume so. Because there'd be no reason not to.
I guess I was just wondering, like in humans and like other mammals, like land mammals, it's like the primary producer of blood cells.
Right, and because of that, I would assume that they still would. Because I can't see a disadvantage to them having more, especially since they're so large. I mean, not that I just called all whales large, which seems like a disparaging remark, but so we're all clear. Like, whales are big, right?
Why would legs be a disadvantage for a snake?
Why would?
Like, legs be a disadvantage, especially for a land snake?
So, the reason that a leg would be a disadvantage would be speed. If you think about how they move, like for a snake, it would be a matter of slithering back and forth. If you get a leg caught on something, if it's in any way stuck, damaged, an easier way for you to get trapped by whatever's going to eat you. One possibility. We're going to look at another animal that something seems like a very peculiar disadvantage to have. So this is how we use fossil records as evidence for evolution. We go back, we look at the fossils, we look at the structures that exist in the fossils, and they tell us that things changed over time. And not only do they tell us that they changed over time, sometimes they can give us evidence of how they changed over time. Sometimes they can allow us to do this. Actually, these aren't even fossils. These are just bones. You guys should recognize the term homology. These are structural homologies between the human, the cat, the whale, and the bat. They're all mammals, right? What this diagram is showing us is that if we look at these structures, These originated from the same place in the mammalian ancestor. It was the same structure that gave rise to these structures. So the bat's wing is really just the equivalent or the analogous of our arm. Has all the same bones, all the same pieces in there compose that wing. What happened to separate us is not any different than what happened for Darwin's finches. They separated, that mammalian ancestor ended up in different environments. Some things were advantages, some things were disadvantages. So we selected for some traits, we selected against some traits. So those are structural homologies. Don't make fun of this guy either. It's not his fault. There are two things about this fish that's weird. It's transparent. It lacks pigment. Why do we have coloration? Same reason I said that I personally would not be a good paleontologist, because me in deserts, I create less melanin. Melanin protects me from what? The sun. He doesn't have pigments. Pigments protect you from the sun. Why would he lack pigments?
Because he lives so far down.
He lives somewhere where there's no sun. The pigments aren't going to do him any good. They don't provide him any advantage. In some instances, they would have probably been a disadvantage for him, which is why over time, he wouldn't have pigments. What else is he missing?
Eyes.
Yeah, you live in a cave. He has no eyes. He has an eye socket, but he has no eye. They don't need an eye because they live at the bottom of the ocean in caves. Pigment and eyes do you no good there.
How do they eat?
How do they eat? No, they just grab food.